Welcome to this tutorial on preparing algorithm Docker container images for the HNTS-MRG 2024 challenge. My name is Kareem, and I'll be walking you through this process step by step. So I'm here on the main branch of the GitHub. I navigate to this Docker tutorial folder where there's a README with extensive details on how to do everything. We're basically going to go through some of this pretty quickly. So step one, prerequisites. I'm just gonna be running this tutorial out of my Mac and not using any GPU support, but probably a good deal if you're going to be using WSL2 and need to be testing with your GPU. So please look over those details here. First thing, obviously, is to ensure that Docker is installed in your system by following the instructions on the official Docker website. We recommend installing Docker Desktop for ease of use. So I have Docker Desktop here. And so you can go ahead and clone this repository by copying that command into your terminal. So I have this terminal in a folder that I want to clone this repository to. I'll put that command, start cloning in. I'm gonna fast forward through this just because it takes a couple seconds. So fast forwarded, and we've cloned into the repository. So I've put that here in this folder location, so HNTS-MRG. And then here's all the folders and files. So we're working out of this Docker tutorial folder here. So we'll move on to the next section. So example files overview. So yeah, this repository provides two examples, one for task 1 and one for task 2. Both examples basically have the same exact files and produce a simple segmentation mask output for a given MRI input or set of input for task 2. And so, like we say in the README, the main files that you're working with are these: inference.py, requirements.txt, the Docker file, and these .sh commands. I'll mainly be going through task 1 as an example here. And then a quick note, also, you may get some permission denied errors if you're trying to run these .sh files. So you may need to run this command first before running any of them. So I'll just go ahead and preemptively run it for, oops, got a CD into the right folder. So I will go and then task 1, and then I'll run that chmod for the three .sh files we have in there. Okay. So the main file you're probably going to be modifying, or at least one of the main files we're modifying, is this inference.py. You can add additional functions, include additional scripts or libraries. So in the inference.py script, we have this run function and a series of helper functions below, and the actual inference code here for generating segmentation using this very basic approach. So you're going to most likely replace everything here, particularly the generate segmentation, with whatever functions you want. The important thing is, as long as your location where you're reading the files from and location for where you're writing the files to stays the same. So you're writing to this images MRI head neck segmentation, you're reading from this images pre-RT T2W head neck. As long as that's the same, you should be fine. And this is important because this is the exact format that the grand challenge is going to give you the files to read and then expect the files to be written. So as long as that's maintained, you should be okay. Yeah. The other file that you're going to be modifying most likely is the Docker file. And so you're probably going to change this base image if necessary. And if you plan to include other folders or files that aren't in this resource directory, so we include this resource directory, which with an empty text file basically. But you can place other folders and files in here. But if you plan to use anything other than this, make sure you copy it properly. And yeah, so probably, as you modify your inference.py, this Docker file is going to have to change so that it can adequately run that inference.py. And ChatGPT, other LLMs are probably going to be your friend to make this into the right format. But something that's important is that at the end of the day, when you get all of this done, you're going to have a zipped file containing your Docker container image, and that has to be under 10 gigabytes. And usually, like, this Docker file is the culprit for having like overly large built container images. So that's something you're also going to need to be cognizant about. Just make sure at the end of this, you need to make a Docker build that is less than 10 gigabytes, and usually you'll have to modify this Docker file to make it more lean and compact. Okay, yeah. Last thing, you also have requirements text file, obviously. So uh, you know, add in the libraries that you need there. Okay, okay. So we'll go on to the next section, which is building your Docker container image. So you should be able to, assuming you ran that permissions command, you should be able to just run this out of your terminal. So, once you have all of your inference code integrated into that inference.py script and your Docker file modified, we'll want to build it, build the Docker container image. So we'll call this, I should just copy here, paste there. We'll build it. As this will take a couple seconds. For this particular example, this task one example that I'm running, it'll be really quick. But more likely, if you're doing, anything fancy like deep learning in your algorithm, this is going to take a while to build, depending on how many, requirements that Docker file has in it. But it could take quite a while. So this will be quick. I'll speed to the end here. Yeah, so that took about 30 seconds. Okay, so the Docker container image is now built. Then you testing your Docker container image. So we've built the Docker container image. We're not going to test if it actually works on a set of example data. So we provided some example data here in test/input for each of those tasks. So task one, test/input, and we already kind of talked about this. So that's an MHA file there. Similar layout for task two, but with the 5 folders instead. So in this particular example, this is a patient from the training set, patient ID 86, which you probably already have downloaded from Zenodo. Okay, and one quick thing also. So when we're talking about task two, unfortunately, one of the inputs was unable to be let me make this longer here. One of the inputs wasn't able to be uploaded to GitHub just because of its size. So this registered pre-RT head neck, which is the registered pre-RT image that has been registered to the mid-RT image, was too large. So you'll have to download it from this Google Drive location. So just download that. And it'll download, and just be sure to put it inside the corresponding folder here. So I'll just quickly do that. All right, we fast forwarded to get this file, and just drag your file in there, and you should have all the files you need after that. But yeah, sorry about that. We weren't able to upload that particular file to GitHub. But anyways, so yeah, what you're gonna do is you're going to run this command to test your container, which has already been built. So we'll go back to the terminal. Excuse me. We'll go back to the terminal and copy this command here, and we'll paste the command in here, and that'll one, it'll rebuild the container, but because we already built it in the previous step, it kind of skips that part, and then it actually does this test run, which is basically just running your script on that input patient and trying to output the corresponding mask. That you may need to enter your password if you've set one, and then so it wrote the result here, and so we'll just go there really quickly. Task one, test output images segmentation. And so yeah, it just created this file. I know there was something in there before, but just for illustrative purposes, I'll just run the test run again, and you'll see that it'll create the file here. So we'll run it. It's running. And then it wrote the file right there. Okay. You can also look at the outputs of your segmentation mask in 3D Slicer. So we can just drop in the input image here as a volume, OK. And then we can drop in the output that we just generated. Click show options and then label map. And we can see the generated segmentation. So in this case, it was a kind of toy example where the green is the primary tumor and the yellow is a lymph node. Before moving forward, I also want to quickly note that you are going to probably have to modify the test run .sh file if you are planning to use GPU support for your local testing. You don't have to use GPU support when you're testing it locally, but you probably do want to do that. So, we included this, thing that you can uncomment, and it'll enable the GPUs all flag inside the Docker run command. So you could go ahead and do that if you plan on using GPUs for your local testing. At this stage, you should you should have established that your container image is running properly on the example data. And the last thing you're going to do is save your built Docker container as a zip file. So we've established that everything's working correctly. And our last step here is to just export into a zip file. So we have a command where we have a sh file where you can run it and it'll do it for you. So we'll just copy that, run that. And so again, it's going to rebuild the container, but in our case, we already built it. So it's just going to do that exporting command, zipping command. This will take a while, depending on the size of your actual underlying container image. So this could take anywhere between a couple minutes to like 30 minutes, depending. So I'll fast forward through this. Okay, so the Docker image successfully wrote to the zipped file. It took about 10 minutes. And yeah, this is where the file is. And yeah, this one is about 3.5 gigabytes. So yeah, the larger your actual Docker, container images, the longer it'll take to zip it, obviously. Okay, so moving on to the next section. Actually, okay, so that's the end there. And I mentioned here that instead of running the export.sh file, you could also just directly call the save command in Docker, and then this way, and then rename it to whatever you want. Okay, so that's the end of the tutorial. At this point, you have your zipped Docker container image, which can now be uploaded to the Grand Challenge website. So the next video is going to tell you all the steps for that. All right, well, thank you for your time and good luck with the competition.